Dear students, in the previous lecture video we saw this problem. Today we are going to see another problem. The difference between this problem and the problem we are going to see now varies a little bit. What is the variation? So here there are no infinities here, right? Only finite points given in input as well as output. There are no infinities, kindly keep it in mind, because there are only two models in this bilinear transformation problems, that is finding out bilinear transformation when we are given input and output. There are only two models. One is involved with only finite points and the other one is involved with both finite as well as infinite points. See here, these points are finite and one point is infinity here. That is what the major difference between that problem and this one. There is a little bit variation in the initial step itself. I will tell you that before going there. The problem is the same pattern, the bilinear transformation only we are going to find out. Again, three inputs were given, three outputs were given. In the output, one point is infinity here. It can be in the input also, no issues. Only two patterns. One is only finite points involved, and the another one is both finite and infinite. Infinity will be one of the point here, right? After finding out the bilinear transformation, using that transformation, I am going to find out the invariant points. Invariant points are fixed points, whatever they may ask. Again, in the previous problem, whatever we saw, the same thing we have written the data as Z1, Z2, Z3, and this is W1, W2, W3. Again, we are writing out the same formula. See the previous problem also, the same thing will be continuing. Just check it out. See, this is the previous problem we did. All the finite points, and again we are writing out the formula. Again, our aim is to find out the value of W, which should be in the terms of Z. See, what we did there is, we have directly substituted whatever the points given there, right? Just check it out from the initial step itself. First step, I am writing out the formula. After that, what I am doing is, I am simply substituting whatever the values are given. If all points are finite, this is the case. If at least one point is infinity here, anything, anyone among this, that is Z1, Z2, Z3, W1, W2, W3, among this, if any point is infinity, we are not going to substitute in the initial step itself. Some alterations to be made. What were those alterations? Just check it out. See, here W3 is infinity, so I am taking W3 outside of from this term and this term, right? Keep it in mind. Suppose if Z2 is also infinity, instead of Z2 equal to 1, if the case is Z2 is infinity, what we will be doing here is, I will be taking Z2 outside from this as well as from this. Whatever points were given infinity, we should take those terms outside. Whatever points given as infinity, we should take those points outside as common. See here, W3 is infinity, so I am taking out W3 from this term. So the formula changes like this, that is W3, if I am taking it outside, means it will be W2 by W3 minus 1. Similarly, in the denominator, I am taking out W3, so the term will become W by W3 minus 1. Okay? There are no changes in the remaining terms. Why? Because only W3 is infinity, so I am disturbing the terms wherever W3 occurs. Wherever W3 is present, I am just changing those terms alone, not touching the other terms. The remaining terms were as such. This term has not changed and this term has not changed, and the right hand side has not changed thoroughly. Why? Because no points in Z series were infinity. If any terms were infinity here, I will be changing in the same manner as I did for W3. Keep this in mind. Whenever infinity is involved, we are not supposed to substitute it directly. Keep this in mind. Right? The next step I am going to substitute. Whatever the values we are given, the next step we are going to substitute. See, for W1 is minus 1. So I will be having W plus 1. Then W3 is infinity. So anything by infinity is 0. So I am not going to concentrate on the numerator as much. Anyway, I am substituting W2 as 0. Then W3 is infinity, minus 1. W by infinity minus 1. I am substituting those values. That's it. Very simple. I am substituting the values of Z1, Z2, Z3 in this step. The next step I am simplifying. That is, anything by infinity is 0. So 0 minus 1 will become minus 1. The same thing here. 0 minus infinity minus 1. Sorry. Anything by infinity is 0. 0 minus 1 is minus 1 and 0 plus 1 is 1. Here Z into 2 by Z plus 1. So the terms will simplify like this. W plus 1. This minus 1 gets cancelled. So W plus 1 by 1 gives you W plus 1. This is 2Z by Z plus 1. See, this problem is very simple. In the next step itself we can find out the value of W. That is 2Z by Z plus 1 minus 1. Our aim is to find out the value of W, and simplifying that I will be getting out the value of W. As I said in the previous lecture, it is easy to verify whether our answer is right or not. The only thing what we have to do is, in the transformation, I have to substitute the inputs as well as outputs. That is what. What were the inputs given? Input is Z equal to 0. When I am going to substitute Z equal to 0, I should get Z equal to minus 1. You should do for all the points. Why? Because it may come in 1, it may come for 1, but it may not come for another 1 if you are wrong. If you are right, for all the inputs, you will get the outputs as given in the problem. Okay? So I am doing those steps here. So all those have been verified. Just very simple. Just see here, I am putting Z equal to 0. W equal to, the transformation is Z minus 1 by Z plus 1. So I am putting Z equal to 0. So 0 minus 1 by 0 plus 1. This implies W equal to minus 1. So similarly I am putting Z equal to 1. So 1 minus 1 by 1 plus 1. This implies W equal to 0. Because numerator is 0. 0 by anything is 0. And the last one, Z equal to minus 1. So minus 1 by minus 1 plus 1. The denominator is 0. So I am getting W equals to infinity. So we can be sure on the exam hall we are right. We are getting out 8 marks out of 8. Right? So the next thing is to find out the invariant points. As explained in the definition lecture video, what are the invariant points? Invariant points are the points which won't vary when we are applying it to the transformation. That is, the transformation's role is to change the input. But the invariant points, its nature is it won't change whenever it is applied to the transformation. How can we find out the invariant point? I can just replace W equal to Z. That is it. Okay. So I am replacing W equal to Z. So on simplifying this, I am just cross multiplying Z into Z plus 1 is Z square plus Z. That is, this term will go here, right? Equal to Z minus 1. The next step, I am bringing out all the right hand side terms here. So I am getting Z square plus 1 equal to 0. So Z square equal to minus 1 is Z equal to root of minus 1, which is Z equal to plus or minus I. Therefore the invariant points are Z equal to I comma minus I. Okay. Let's have a look at this problem and work on those two problems, this problem as well as this problem. Well, because working out on the initial problems, whatever explained in the lecture video, as well as it will be given as a material. If you are having those contents in your hand and with that you are practicing, it will help you a lot. First do those two problems without seeing, right? Then go to the other problems. All the best.